Hey everyone, so today we're going to be working with VLANs and inter-VLAN connectivity. This method we're going to be using today is going to be called router on a stick. So essentially what we're going to be doing is creating a couple sub-interfaces that are going to represent the default gateways of each VLAN that we're going to configure, one for engineering, one for sales. And yeah, that's going to pretty much route the traffic across the VLAN. So any traffic from VLAN 10 should be able to reach VLAN 20 and vice versa. But first, what we have to do is configure VTP settings on each one of these three switches. This one's going to be in a server mode, this one is going to be transparent, and this one's going to be the client. I'll delve into that a little further as we go about the configuration. But yes, let's get started. So I'm gonna open up switch 1 here, and then let's expand this a little bit. Alright, so first thing we're going to do is we're going to check the encapsulation on these interfaces, the default trunk encapsulation, or administrative trunk encapsulation, I should say. And make sure those are set at .1q. Foundational principle of ensuring that you can have VLAN traffic on your network is you're going to want to configure your trunk ports. So each one of these trunk ports connecting to the switches, or each one of these ports connecting to the switches, are going to be configured as trunk ports. This one right here, F01 going up to the router, will be as well. That way it can send both VLAN traffic up to this interface and delegate, which packet is going to which VLAN. So in order to check that out, we want to use the show interface and then switch port command. So that's interface G01 and switch port. As you can see, the administrative trunk encapsulation is set to .1q, so we should be good there. So let's just hop into global configuration mode, G01, and do a switch port mode trunk command. Alright, so that one is trunking. We're going to work our way over here and check for the same thing. First, I want to show you, though, what will happen if you try to configure an interface as a trunk when it's using a negotiated encapsulation in comparison to the .1q. So let's go to int range G01 to 2, and we're going to do switch port mode trunk. As you can see, it'll reject the command because the encapsulation is set to auto, and that'll be displayed as negotiated in this output right here with the show int switch port command. So there it is. So we got to go back and set that trunk encapsulation to .1q instead. So we're going to go to global config, int range G0122, and the command to set that trunking encapsulation to .1q is switch port trunk encapsulation and .1q. And then now we can configure those as trunk ports. Switch port mode trunk. Alright, so those are trunking now. And we want to do that for the F01 interface going up to the router. So we got to do the switch port trunk encapsulation .1q command again, and then switch port mode trunk. Okay, so all of our interfaces on switch 2 are trunking, and now switch 3, we got the G02 interface. So let's do that. Oh, shoot. Anytime that happens in Packet Tracer, just hit Control Shift and 6, and then it should cancel out the command. That'll happen sometimes. Global config and G02, and then switch port mode trunk. Alright, so its encapsulation was set to .1Q, which is why we didn't encounter an error there. Alright, so all of our interfaces are trunking now. From here, we want to configure the VTP mode. So like I was saying, this one's going to be the server, this one's going to be in transparent mode, and this one's going to be a client mode. So when we configure this one as a client, it will get the configurations that we make on the switch that is in server mode. It'll pass that traffic down. This will be in transparent mode, so it won't participate in the VTP domain that these two are going to be in. However, it will still forward that VLAN traffic and allow the client to receive the configuration from our server switch right here. But first and foremost, I want to make this one transparent. So we're going to do that with a VTP mode transparent. Oops. Transparent. Okay. So it's in transparent mode. We're going to put it in VTP domain of CCNA, which are going to be the same domain that the other two are going to be in. And we're going to configure our VLANs individually here. Like I was stated previously, this is going to be in transparent mode, so it's not going to receive any configurations that we make on the server switch. So we have to configure the VLANs separately on this switch in particular. So VLAN 10 is going to be for engineering. And then VLAN 20 is going to be for sales. Alright, don't know what was up with that. Alright, VLAN 20, name sales, and then VLAN 199. We're going to switch our native VLAN from 1 to 199. By default, the native VLAN is always set to 1. That's common knowledge. We kind of don't want everybody to know what our native VLAN is. Not ideal. So we're going to configure VLAN 199 as our native VLAN. Give that the name of native. Okay. And then since that's going to be our native VLAN, we're going to configure the interfaces with this set to their native VLAN as well, but we're going to wait to do that until after I configure the server and client. So we're going to make this one client mode, and then we can hop over to switch 1 and make the configurations, and they should all get passed down to switch 3. Alright, so on switch 1, we're going to do VTP mode server. Alright, it's already in there. Then we're going to configure it with the domain of CCNA and configure our VLAN. So VLAN 10, same thing. We're going to give it the name of engineering. VLAN 20 is going to be for our sales department. And then VLAN 199 is going to be our native VLAN. Alright, so just double checking, making sure that all that is good to go. Let's check out our show VLAN brief on switch 1. As you can see, we have our 3 configured VLANs. Now let's see if those got sent to switch 3. Right, we'll do another show VLAN brief. And as you can see, that got passed down as well, so we got those. Alright, so it's all trunking. Our VLANs are configured. Now we have to place our client devices into the correct VLANs. So the 10.10.10 devices are going into VLAN 10, and the 10.10.20 devices will be going into VLAN 20. So we're going to have to do that for switch 1 and switch 3. So let's start with switch 1. Both interfaces, F01 and F02, going to be in VLAN 10. So we'll do an int range F0122. We're going to make sure they are in access mode. So switch port mode access, and then switch port access VLAN 10. So only VLAN 10 traffic is going to be allowed on those. And we're going to go to F03, switch port mode access again, and switch port access VLAN 20. Okay, so it's done on that side, and then we got to do it on this side as well. So again, int range, the F01 and 02 interfaces are going to be in VLAN 20 on this one. Int range F0122, switch port mode access, and then switch port access VLAN 20, and then the F03 interface. Is on VLAN 10. Okay, so now that we got those configured, we're going to check the connectivity. So all the clients on this side should be able, well, in VLAN 10, should be able to ping any client device in its own VLAN on this side. Alright, so we're gonna hop on here. I'm gonna wait for this to configure. Let's just check out VLAN 20 first while that's getting situated. Alright, so we're going to do, whoops, ping 10.10.20.12. Alright, so we got a reply from that end, which is great. So VLAN 20 has connectivity between all its devices. Now, let's make sure VLAN 10 is doing the same thing. So we're going to ping engineering 3, ping 10.10.10.12. Alright, so we got a reply from that end as well. So all of our VLANs are working correctly. They shouldn't be able to ping, like VLAN 10 shouldn't be able to ping VLAN 20, just because we haven't gotten that routing situation set up yet. So just to show you, I'm on engineering, we're going to ping a device in VLAN 20 and see if it works. And this should time out. As you can see, it's not cooperating. But that'll get taken care of when we configure router on a stick with our router over here. So this is set to trunk mode, so we should be good there. And now we want to bring this F00 interface up on router 1 and then configure our sub interfaces for the default gateways of engineering on VLAN 10 and sales on VLAN 20. I'll show you how to do that here. Alright, so we're in global configuration mode, int F00. Let's bring this up with the no shutdown command. Alright, perfect. So that's up. And then we want to configure our sub interfaces. So in order to do that, we just type the interface that we just put up, but the sub interface will be defined by a dot and then whatever number VLAN you want it associated with. So in this case, we want it associated with VLAN 10, so we're going to do a 0.10. Alright, so the sub interface is up now. We want to make sure that it is using .1q encapsulation, so we use the encapsulation.1q command, and then you want to specify the VLAN number that this sub interface is going to be associated with, which is 10, and we're going to give it an IP address of the 10.10.10.1 with a /24 mask. Alright, so that one's up, and then we'll do the same thing for VLAN 20. So we'll do the 0/0.20. That one's up. We'll do an encap.1q 20 and an IP address of 10.10.20.1 with the /24 mask. Alright, so that's perfect. We should have inter-VLAN connectivity through router on a stick method now. Let's check it out. So we'll go on to this PC right here on VLAN 10, and let's see if it can reach one of these PCs over on VLAN 20. So here's the moment of truth. Go on command prompt. Ping 10.10.20.11. Should take just a second to get through here. And perfect. As you can see, we have inter-VLAN connectivity now through router on a stick. That is all I got for you in this video. Stay tuned for layer 3 inter-VLAN connectivity in the next one. Thanks.